All right, hello everyone, and welcome to 12-Factor App, Best Practices for Java Deployment. Before we get started, I have a slight warning. It's not a health warning, but this talk may upset you. You may not like some of the things that I'm going to say. And the reason for this is that the ideas I'm going to talk about are, not to overstate things, but a little revolutionary, but they're different. They're a departure from what I would call traditional Java deployment. What I'm going to talk about is what I call modern Java deployment. And it's characterized by a departure from this. You take your code, you package it up into a WAR file, and you drop it into a running container, Tomcat, Jetty, JBoss, something like that. And this is how we've deployed our Java applications since about 1999. There's some problems with this architecture, though. It predates the cloud, it predates virtualization. It really wasn't designed for a web-native, cloud-native era. So modern Java deployment looks more like this. You take your code, you package it up into an executable jar file, or maybe a set of jar files, and then you can deploy that jar file anywhere. Anywhere that there is a JVM, this jar file can run because it doesn't have any external dependencies. It can run in the cloud, it can run on another developer's machine, it can run on a Raspberry Pi. So what we get is true portability. Finally get to embrace that promise of the JVM. So what I'm really saying is make jar, not war. Josh Long likes to use this phrase too, but he stole it from me and I stole it from someone else. So we've agreed to both use it. This shift from WAR files to jar files is not the only thing that characterizes modern Java deployment, though. Over the last 5 or 10 years, we're seeing a shift away from application servers and towards microservices. So instead of running many applications in the same process or in the same container, we're splitting our applications up, decomposing them into smaller, more cohesive components. We're also seeing a shift away from hot deployment. Hot deployment was this idea that we could redeploy our applications into the same JVM, keep it running, a persistent JVM. But due to permgen, memory leaks, system updates, system crashes, there was always a need to restart that process for whatever reason. And by optimizing for hot deployment, we paid the price of having long restart cycles. Instead, today, the emphasis is on continuous deployment. So the idea that you're going to deploy your application maybe as much as multiple times a day, and the goal should be to reduce the turnaround cycle on each of those deployments. And then finally, 10 years ago, I was deploying the applications I was working on to a piece of hardware that was in the physical building I was working in. But today, most of us are deploying to some kind of cloud platform, whether it's Heroku or Amazon. If you're deploying in-house, you're still probably deploying on some kind of virtualization layer or even in-house cloud. So Heroku is where I work. My name is Joe Kutner. I go by Codefinger on all the internet places. Heroku is a platform as a service for running your applications in the cloud without managing any infrastructure, even virtual infrastructure. We host more than 5 million applications, and we handle more than 8 billion requests a day. And we've learned a thing or two about scalability in that process. So I am responsible for all the JVM applications that run on Heroku, making sure that they work and that our customers have a pleasant experience. So I've been able to work with a lot of different kinds of apps. And we've seen what works, what doesn't work, when there are problems, what are those solutions. And from that, we've derived this methodology, this manifesto that we call the 12-Factor App. It is a set of principles, a set of best practices that we have found lead to more scalable, maintainable, and portable applications. So it is portable. This is what we've derived from our experiences on Heroku, but it's by no means specific to Heroku. It really applies to any kind of deployment. The mechanisms through which it achieves these characteristics are immutability, immutable infrastructures, ephemerality, the idea that your applications are not persistent, they will be disposed of or restarted at some time, declarative setups, declarative configurations, and then automating as much as possible. So as I talk about the 12-Factor App today, I'm going to be talking specifically how it pertains to the Java ecosystem, and through that I'll be talking about how to implement these mechanisms in a Java application. Is anybody angry yet? All right, nobody's walked out in disgust, so that's a good thing, but maybe I have more work to do. All right, so without further ado, here are the 12 factors. Soak them up, I'm not going to quiz you at the end, but you will need to memorize them. The first one is Codebase. So this is a factor, a principle that states you should use version control. Now, I know what you're thinking, and I promise you're going to learn some new things today, but I have to say these sort of elementary principles because there are people that need to hear them. But even if you are already using version control, you should be using it in the proper way. And that is one repository per application. And then you deploy that application to multiple environments. You should, of course, not manually fork the repository for different environments. That would undermine the version control system. But, and this is more common, you should refrain from having multiple applications in the same repository. This becomes a problem because the history for these applications becomes entangled, and it becomes difficult to isolate them, to do isolated rollbacks. If you have a problem with one application, you may not be able to separate the commit history of each of them. You'll have commits that apply to both. And in general, it just reduces your ability to decouple them. They should be independent applications. Now, the reason that we see this happen very often is that it's convenient to have multiple applications, sometimes as Maven submodules or some other similar mechanism. And we do this so that we can automate processes or share dependencies. And those are good things. So if you're going to use Maven submodules or something like this, you should also make those Git submodules or whatever mechanism applies to your version control system. That is, making sure that they retain their own commit history, even if they're sitting in the same physical directory. Now, as I said, the most common, or one of the most common reasons for doing that, combining projects, is to share dependencies, and that brings us to the next factor. Dependencies in the 12-factor app should be explicitly declared and isolated, and you should never rely on the implicit existence of system-wide packages. So one of the things that implies is don't check jar files into Git. Now, you probably know you're not supposed to do that, but we've probably all done it. It's just easy to do sometimes, and it's just easier than setting up a Maven repository and hosting this thing that has to, coordinate with other build processes. But that's a problem that's been around for a long time, but it's actually getting quite better. There's a great website you've probably heard of, bintray.com. Makes it very easy to host your Maven and Java artifacts in the cloud. So I recommend that you check that out, create an account. Now, the most common kind of jar file that I see checked into Git repositories is our agent jar files. So these are jar files that aren't necessarily a dependency of your application. Your application may run just fine without them, but you need them at runtime. So even this kind of jar file can be managed. So this is an example of including the New Relic jar file or agent jar file into your project by manually configuring the Maven's dependency plugin. Similar mechanism can be done in Gradle. This is an example of incorporating the Jetty runner, which is a standalone Jetty server that you can use to run a war file in a 12-factor app way, and then just copy this into your project so it's available at runtime. Now, dependencies are a type of configuration, but they're not the kind of configuration that the 12-factor app talks about. So before we talk about this principle, we need to define what we mean by configuration. And configuration in the context of the 12-factor app is anything that changes between deployment environments. So this includes things like resource handles to databases, memcached, any kind of backing service, credentials to external services like Amazon and Twitter, and then per deployment values such as host name, that kind of thing, anything that changes. So this does not include dependencies. Those should stay the same throughout your environments, or things like your configuration routes if your particular web framework has such a thing. Those are the types of things that stay the same. The type of configuration that changes should be strictly separated from your code. It should not be a part of your code base. So in other words, don't check passwords into Git. Now, I know you wouldn't check your own password into Git, I think. But you've probably checked in some Amazon tokens, a database password. But let me tell you something. GitHub, even private repositories, are stored in clear text, plain text, on a server somewhere, probably in California. So if you're checking your passwords into GitHub or something like that, you are inherently insecure. So this is a problem for security, checking passwords and things in, but it's also a problem for portability, because when you include passwords, credentials, things like that as part of your application, it means that if you need to stand up a new environment, whether it's a test environment or a new production environment, you're going to have to make a commit to your code base in order to change those variables. So this kind of configuration needs to go somewhere. If it's not in our app, it needs to go in the environment, and specifically as environment variables. Now the mechanism for this, if you're using Heroku, is managed for you. Many platforms as a service will do that. If you're not, there are things like a Spring Cloud config server, a server that provides configuration as a service. But in some fashion, you're going to need to have a safe box, and it's really up to you to decide what that is. But once you have those environment variables, you should be able to extract them. Most standard configuration file formats or web framework configurations have a mechanism for pulling these environment variables out and into your app's properties. So this is an example of a Spring configuration that is not an XML file. All right, so here's a good litmus test for this principle. If you can make your application open source at any moment without compromising any credentials to your systems, then you very likely satisfy this principle, or you're at least well on your way. All right, so that brings us to the next factor, which is backing services. Backing services are any kind of service data store that backs up your system. So things like Postgres, Redis, Memcache. These types of backing services in a 12-factor app should be treated as attachable resources, and they should be attachable via a single URL. And that URL should be stored as an environment variable so that it can be changed between environments. Certainly you'll probably have a different database between environments. And also so that you can swap it out if you need to do backups and restores of that service or data store. You can do that without, again, making a change to your code base. All right, the last factor before I take a step back and do a demo is build, release, and run. This is a principle that states your deployment process should be executed in 3 discrete steps. Ideally, these are all automated into a single step, but under the covers, there should be these discrete operations nonetheless. Build, in which you compile your code, generate some kind of build artifact, probably a jar file. Release, in which you combine those build artifacts with the configuration for a particular environment, because that configuration should be separated from your code. And you prepare a release image. That image represents everything your application needs to run. And then finally, you run that application from the release image. So to demonstrate this, the build step depends on the build tool you're using. It could be a Maven install, a Gradle build, whatever you're using. The release phase really depends on the platform you're deploying to. If you're deploying to Heroku, it's a Heroku deploy jar or a Maven Heroku deploy. If you're deploying with Docker, it might be a Docker push. But regardless of the system that you're deploying to, the key thing here is it's a single step, a single command, and it prepares that release image. And then finally, running your application, again, depends on the type of application you're executing. If it's an executable jar or an executable war, it's just a Java command. Many frameworks will actually generate a launcher script for you. That's fine too. The key thing here is that it is a single command that launches a foreground process. We are not starting up a service in the background and copying a war file into it. We're also not using Maven to run our applications in production. Maven is a build tool. It's like the parent getting the kid ready for college and then sending it off into the world. It doesn't need to go along with it. Just use it for build time. And of course, if possible, combine all these 3 steps into a single step. When you deploy to Heroku, most of our customers are running git push Heroku master. All right, so let's take a look at how all these first few steps play out together. I have the Spring CLI installed here, a slightly older version, but I'm going to create a new Spring Boot application. And Spring Boot very much embraces these 12-factor principles, so it's a great example of how they execute. So I'm going to create a new Spring Boot web application called Demo. It creates the basic scaffolding of a Spring Boot application for me, including this demo application.java. I'll open that up, just make it a controller, and then give it a single route, hello world route. But I'll actually print the value of the home environment variable. That'll let me see what actual platform I'm running on. And then I'll run maven clean install locally. That's going to download my dependencies, compile all my code, and ultimately generate a single jar file. And this jar file contains everything my application needs to run in production. It contains the dependencies, the static configuration, and I can run it with a single java-jar command. And when I do that, Spring will start up. It'll start the embedded Tomcat container. I'm not launching a separate container. And then I can very quickly view it in the browser. And there you see it's running on my machine, so it's users Kutner. Now I can deploy this application because it embraces these principles, because it only generates this executable jar file. It's very easy for me to deploy this to a platform as a service. So I'm going to set this up as a Heroku app. I'll create my gitignore file, and I'm going to create a proc file. This proc file is what Heroku uses to determine that run step. So in this proc file, I'll put my web command, just a java-jar command. I am going to set one system property, though, and that's the port that I'm going to bind to. This is a value that changes between environments, so it will be stored as an environment variable, and this is just an example of how many of those things can be pulled in. All right, so then I'll initialize a Git repository, so I can use Heroku's Git deployment. When I run Heroku create using the Heroku tool belt, this will provision a new Heroku application for me, but it'll also provision a Git repository on the Heroku servers. And it'll add that repository as a remote target for my local Git repository. So I can simply push to that, which will send all of my application code, my POM XML, all of that stuff, up to Heroku. It'll detect that it's a Java application, a Maven application, and it'll compile the code. It'll run the same Maven process that I just ran locally on the Heroku servers, generate that same jar file, and then it's going to package that jar file into a release image. So that's what it's doing in those last steps there. And because I have that release image, I can very easily launch processes off of it. So I can use Heroku PS to see the status of that process, and there you see that java-jar command getting started on one instance. And I can view the logs for this process with Heroku logs. And there you see this, essentially the same thing that we saw locally happening on Heroku. And finally, Heroku open to view the application in a browser. And there you see it's running from the app directory on the Heroku platform instead of my local machine. All right, just a few more commands, and I'll show how this is done from the web. So Heroku releases shows me a history of my deployments. So each time I deploy, I'm getting a new release image. And I can version those release images so that if I deploy changes that are breaking or cause problems, I can quickly roll back to a previous image without redeploying my application and launch those processes again so I don't experience much downtime. And then I can debug that problematic release offline. Finally, I can start one-off processes as well. So if I execute Heroku, first, I'm going to scale my application up. So by running the PS scale, I can create new instances of my application. So if I run Heroku PS again, I'll see I have that original Web 1 instance still running and 4 new ones starting up, and in just a few seconds, they'll be ready to go. And I can scale back down just as easily. So very quickly moving to meet demand and then returning those resources back so I don't have to pay for them. All right, here's the Heroku run bash command, which is going to start a one-off process on the Heroku servers from my release image. So I'll have the context of my application available to me to execute commands. My jar file will be there. Most often this is used to run one-off tasks like migrations, things like that. And so all of these commands I'm doing at the command line can also be done from the web. There's a great Spring Boot example app on GitHub. It has this button you can click, which will essentially do the same thing as the git push Heroku master, just without the command line. When you click deploy, it'll run the same Maven process that we saw locally and then on the Heroku servers earlier. It'll generate that same release image and then launch a new application process. So I can click view to see it. This is a slightly more involved example application. I can manage the app here. I can view metrics, deployment history. I can view an activity of who's been, if other people have access to it, who's been deploying, who's been changing variables, things like that. I can also change my payment plan or scale up. So just as I ran the Heroku PS scale, I can just move this slider. So same basic principle. All right, and so all of that is possible because because of these 12 factors. Because Spring Boot embraces these principles, it allows me to rapidly scale up and to easily manage my application. Anybody unhappy? Okay. All right, so those first set of principles apply to sort of your deployment process, your build process. But these next set of principles that we're going to talk about are more about your application's architecture, how you design your application, how you build your application. The first one is processes. In the 12-factor app, processes should be stateless. So if you have an application process that crashes for whatever reason, it should not take anything important with it. For the most part, this means sticky sessions are bad. So sticky sessions are this mechanism where once a user creates a session, their requests will always be routed to the same application process. But they should be able to be sent to any process as needed. However, things like cache, which are keeping things in memory, keeping state, but are still distributing them across multiple processes, these are still okay. All right, the next one is fairly important to Java, port binding. The 12-factor app should be completely self-contained, which means a web app should export HTTP as a service by binding to a port. It should not depend on any external piece of infrastructure to do this for it. So what that means is that traditional deployment violates this principle. In traditional deployment, we depend on that external container to bind to the port and query requests to our application. But in modern Java deployment, our application is completely self-contained. It knows how to do the binding, it knows how to handle requests, and it doesn't rely on that external infrastructure. And of course, this is what we're seeing from all of the modern JVM web frameworks. We saw Spring Boot just a moment ago, Ratpack, Finagle, Play, Wildfly Swarm, Drop Wizard. All of the major modern JVM web frameworks are embracing this standalone approach. All right, the next principle is concurrency. And you're probably thinking, relax, you got this, right? The JVM has some of the best concurrency libraries available. And that's great for scaling up. You can throw resources at the JVM all day long and it'll do great. But you also need to be able to scale out. And one way in which you scale out is by diversifying workload. So decomposing your application into individual applications that do separate jobs well. That allows you to scale the part of your application that handles web requests without scaling up the part of your application that does background jobs or scheduled jobs. Now, this could be seen as me advocating for microservices, and if that's the way you interpret it, that's fine. That's not really what I'm saying, but I do believe that there are principles associated with a microservices architecture that are just generally good, and there's something that we should all embrace and learn from. And this need to diversify workload is certainly one of them. Some other principles relate to the next factor, disposability. So this is a principle that states your applications should be quick to start up, graceful to shut down, and resilient to failure. So quick to start up means ideally under 1 minute to start an application. Graceful to shut down means when it receives a term signal, it should, within 10 seconds, release any resources, clean up any connections, and shut down gracefully without any residue. And then resilience to failure, in many ways, falls out from these other two characteristics. If you can shut down a process and restart it very quickly, it is, for the most part, resilient. So the reason this principle is important is that for a long time, we've treated our servers as pets. They were special to us. We wanted to keep them healthy. If they were sick, we took them to the vet. You know, they were a part of our lives. They were in the same building as us, for goodness sake. But servers are not pets. Servers are cattle. When you need more servers, you go to the market and you buy them. If a server is sick, you kill it. If you have too many servers, you return them back to the cloud so that you don't have to pay the overhead of keeping them around. Servers are a commodity now. With the cloud, with the cheapness of resources, we don't have to treat them as our special little pets. So back to the Java ecosystem, application servers are pets. They are not disposable. They are these big, heavy components that we always have to take care of. But microservices are more like cattle. They are disposable, they're cheap, we can restart them, we can scale them up. So again, am I advocating for microservices? Maybe. But what I'm really advocating for are these principles. Microservices are easy to replace, easy to modify, and they're decoupled from external infrastructure. And certainly we're hearing many great stories from a lot of major players how this has worked for them. All right, the next factor is my favorite. I think this might be the most important factor, and you'll see why. DevProd parity is a principle that states your development environment should be identical to your production environment and every environment in between. The most common place this is violated is at the database layer. So if you are using Postgres in production, you should be using Postgres in development. I also see this violated at the container layer, and of course, the easiest way to ensure that you're using the same Jetty or Tomcat throughout all environments is to package it into your application. Remove it as an external dependency, keep it managed by creating a standalone application that doesn't depend on anything else. Now, this is an important factor because it prevents you from introducing bugs that you would have otherwise detected sooner. That's true. But it's also important because parity leads to other principles. Parity leads to reproducibility. So if you can mimic your production environment on any other platform, you can quickly stand up a new developer's machine, you can quickly stand up new test environments, you can quickly scale up your production environment. And as soon as you have reproducibility, you are on the way to disposability, because your application, if it can crash and then easily be replaced, or for that matter be destroyed and easily recreated, then it is disposable. So parity is really the first step along the way to disposability. And that's why I think it's so important. All right, the next factor is logs, which is relatively interesting, but very orthogonal to all the other factors. So I'm actually going to skip it and go to admin processes. So admin processes, tasks like background one-off jobs, database migrations, these kinds of admin tasks should be run as isolated processes. So essentially, don't log into a production server that is currently handling requests and try to run a database migration or some one-off job. At the least, you'll steal resources from the other process, and at the worst, you'll crash it for whatever reason. I speak from experience. So when I ran that Heroku run bash command, what I was getting was a new container, a new isolated process in which I can run commands in the environment of my application without affecting the other processes. In fact, it's almost identical to the Heroku PS scale command. So as I'm scaling up new web instances, I'm actually doing the same thing, creating new containers. The only difference with that admin instance is that it doesn't start up the web process. So again, we have parity between each of these processes. They are essentially the same thing, but they're isolated from each other. All right, so let's recap. Codebase. You should use version control, but you should strive to use one version control repository per application. Your dependencies should be explicitly managed. Don't check jar files into Git. Configuration should be strictly separated from the code, and it should be stored in your environment, not in your application. Backing services, things like Postgres and Memcached, should be treated as attachable resources attached via a URL. Build, release, and run should be the 3 discrete steps you use to deploy your application. Your processes should be stateless. Port binding should be done by your application, not by an external piece of infrastructure. Concurrency, you should be able to scale up as well as scaling out, and you scale out by diversifying workload. Disposability, your application should be quick to start up, graceful to shut down, and resilient to failure. Treat your servers as cattle. DevProd parity, the equivalence between all environments, dev, production, test, stage. And then admin processes should be run in these isolated one-off containers. You can learn more about the 12-factor app at 12factor.net. This is where we have a sort of manifesto for the 12-factor principles. It is a language-agnostic methodology, so it's not specific to Java or any other language. So what you read there is very general in some sense. On my blog, Kutner on github.io, I very often write about how these principles relate to the JVM and to various JVM languages. So if you're looking for more information, that's a good place to go. So what's next? You now know the 12-factor app. Congratulations. What do you do about it? So I'm going to give you 4 action items that I'd like you to execute at some time after leaving here. The first is create a bin tray account. Even if you don't plan to use it, just go create the account, check it out. I think you'll be pleased. The second is set an environment variable for your database. You probably have a database, I'm safe to assume. If you don't, pick something else. Just set that environment variable. Even if you're not going to use it, just set it. And then you can start to figure out how you might switch over to that. It's the first step along the way to separating from your code. The third is measure your app's boot time. So get a stopwatch, take it out on your phone, start your app, and see exactly how long it takes between starting it and it binding to a port and being ready to handle requests. If it's more than a minute, start looking at what you can extract from the application, what you can separate out, what maybe doesn't have to be done at startup time, all in the effort to reduce your boot time. And then finally, try clicking a Heroku button. I get to plug Heroku. That sample app that you saw me demonstrate is on GitHub. Hopefully you can see the URL there. It's a great little Spring Boot. If you're looking to get familiar with Spring Boot, this is another great way to do that, and should be very easy to deploy on Heroku. All right, thank you very much. These slides are on the web, and I guess we'll do questions. I guess. Yeah.
So you skipped logs. Can you say something about logs?
Sure. Yeah. I mean, it's a very interesting. The question was about the logs. It really boils down to logs should be treated as events, not as files. So, at some point you may be writing to a file, but you should be draining that file, or we actually encourage just logging to standard out and then capturing standard out, and that's what happens on Heroku. But by treating them as events, it allows you to collect from different processes, whether it's your database, your multiple application processes and workers. They can all funnel into the same channel, which you can then search on. And that allows you to more easily identify problems rather than having to scour multiple servers for a log file that's in a particular place. That's the gist of it. But, yeah. All right, well, I'll be hanging out at the Heroku booth downstairs, so if you prefer to ask questions in person, just come on down and we'll chat. Thanks.